So I usually use this question. I've been using this question paper a lot now. It's the November 2018 physics question paper. So can we just go through like a few questions in the multiple choice section?
Yes, sir.
So we're just gonna go through the question, and you will tell me whether you have done the chapter or not. If that's fine, then that's just how we're gonna do it.
Yes, sir, that's fine.
Okay. So they say inertia is the tendency of an object to A, maintain its mass, B, continue in a state of non-uniform motion, remain at rest, or in the state of uniform motion, maintain its velocity when a non-zero force is acting on it. Like, do you know what inertia is? I'm sorry.
Is it C, sir?
E, to remain at rest and uniform motion. Why do you think it's C? Sorry, why do you think it's C?
Because isn't that what the inertia is, sir?
Yeah, I understand that inertia is the tendency of an object to remain unchanged, right? But you can't just say it's C because you have to explain it to me so I can understand that you understand the concept of inertia and why your answer is C. Because they say it remains at rest or in a state of uniform motion. So that just means it's not changed, right?
Yes, sir.
Okay, so let me just draw like a circle around it. Don't worry, like for now, we're just gonna go through it, and then I think it's gonna cut out. Then in the next meeting, I'll explain. We'll go through the memorandum as I explain the answers to you. Is that fine?
Yes, sir, that's fine.
Okay, so they say a person stands in a bathroom scale that is fixed to the floor of a lift, as shown in the diagram. The reading on the scale is at its largest when the lift moves upward at constant speed, downward at constant speed, upward at increasing speed, or downward at increasing speed. Where do you think like the highest reading on the scale is gonna be?
Is it C, sir?
So you're gonna take C. So let's just take C and go on. Or do you want me to like give you the answer now?
It doesn't matter, sir.
Okay. So let's take C, then we go on to 1.3 and it says an object is projected vertically upward and we should ignore the air resistance. As the object rises, its velocity and acceleration are both directed upwards. If its velocity and acceleration are both directed downwards, its velocity but is upward, but its acceleration is downward. Its velocity is downward, but its acceleration is upward. Which one do you think? Like when you throw something up, is the velocity up or is it down? And is the acceleration up or is it down?
I think it's C, sir.
You think it's C? You really like C? So they say the ball P and ball Q have the same mass and are dropped on the concrete floor. Both balls hit the concrete floor at the same velocity. Ball P rebounds with the same vertical velocity, but ball Q rebounds with the speed which is half of that velocity. And we should ignore air resistance. They say which of the following statement regarding the collision of each ball with the concrete floor is correct. They say kinetic energy is conserved for both P and Q. The changing momentum of P is greater than the changing momentum of Q. Contact time with the floor is the same for both balls. And momentum is conserved for the collision of P, but not for the collision of Q. Which answer do you think they think it may be?
Is it B, sir?
B. D. Did you say B?
B, sir.
B.
Yes, sir.
That's interesting. Then 1.5 says if the net work done on a moving object is positive, then we conclude that the kinetic energy of the object is 0, has increased, decreased, or there's no change. Do you know the relationship between kinetic energy and the work done? Yeah.
B, sir.
B.
Yes, sir.
Yeah. And they say, have you done the electromagnetic spectrum? So
Yes, sir.
okay, so they say the spectrum produced by a moving asteroid, as observed from Earth, indicates that the light shifts towards the blue end of the spectrum. Which one of the following frequency combination and distance is correct? So they say the frequency of the observed light increased but the distance decreases. As the frequency increases, the distance increases. As the frequency decreases, the distance decreases. And as the frequency decreases, the distance increases. Which one do you think is right? Like, do you know the relationship between frequency and wavelength?
No, sir.
Um, let me just say um, frequency here. Let me just write it as this. Have you seen it? Uh, um, this is the relationship because this is the relationship between like frequency and wavelength. So let me just let me just show you this formula real quick. Um, why is that? Why is that equation? You know this equation, right? So do you know it? Um, C is equal to lambda F. Have you guys seen this equation before? Like if you can speak, then maybe like I can just have the chat on standby. So like you can just send it to me as a message. So are you familiar with this equation?
And so please repeat.
I was asking if you're familiar with this equation.
Oh, yes, sir.
Yeah, then like from this equation, you can see that the frequency is gonna be equal to the speed of light divided by, right? So from this equation, we can see that frequency is directly proportional to 1 over the wavelength. So frequency is inversely proportional to wavelength. So I'm just gonna, and we mustn't forget that frequency is in per second. So F is in per second, and lambda is in sorry, I just log this out, is in meters. So from all of this, can you tell me like what's the answer for 1.6? Like when the frequency increases, does the distance increase? Or when the frequency increases, does the distance decrease? Or do they both increase simultaneously, or do they both decrease simultaneously? So which answer do you think it is?
I think it's A, sir.
Then we're gonna go for 1.7, which says three charged spheres X, Y, and Z are supported by an insulating thread of equal length hang from a beam as shown in the diagram. Sphere X is negatively charged. X attracts Y, but it repels Z. Okay? So they say, which one of the following statements is correct to conclude sphere Y is positive and X is negative? Sphere Y is positive and X is and Z is positive. Sphere Y is negative and Z is negative. Sphere Y is negative and Z is negative. So from here, which one do you think it is? Because X,
I think it's A, sir.
okay. So they say in the circuit below, the cells and resistors are identical. The cells have negligible internal resistance. The power dissipated in resistor X is P, and the power dissipated in resistor Y is, because all the resistors are equal, and all the cells are equal. You know, they're all identical. So what's your answer?
D, sir.
E. Okay. Then they say, which of the following actions will not cause an increase in the induced EMF of a coil if the coil is rotated in a uniform magnetic field? Rotating the coil faster, increasing the strength of the magnetic field, increasing the number of turns of the coil, replacing the coil with a coil of lower resistance. So they're looking for the one that will not cause an increase in the EMF. But this one is based on generators and motors. So can you get can you get the answer for me?
D, sir.
So they say a learner writes the following statement about the emission spectrum of light in a notebook. An emission spectrum is formed when certain frequencies of electromagnetic radiation pass through a cold gas. The lines in the emission spectrum of an atom have the same frequency as the corresponding lines in the atom's absorption spectra. An emission spectrum is formed when the atom makes transition from a high energy level to a low energy level state. So which of the following combinations is true? Like, is it only one? Is it only two? Is it two or three? And is it one and three?
I think it's C, sir.
C. Only one and two. Okay, but then I still think we have some time. So let me just exit this this meeting. Let me end this meeting so I can save the recording. Then I'll start a new one where we'll look at the memorandum. Is that fine?
Yes, sir.
Okay, let me end this.